Hey, thanks for watching. We have this problem on the board. We have 46x plus 11 over x equals 36. And we're told we have two roots to this equation, alpha and beta. Those can be real or complex. And we need to find 1 over alpha plus 1 over beta. To start with, I want to clean up some things to make it a little easier to deal with. So we'll work with this equation, and I'm going to multiply both sides by x. So we'll have 46x squared plus 11 with the x canceling in the denominator equals 36x. And then we'll just rearrange this so it's going to be a quadratic we're more familiar with. So we'll have 46x minus 36x plus 11 equals 0. Next, with this polynomial, we know we need the roots. So normally what you do is you would attempt to factor this, but I can tell you this doesn't factor with integers. We could use the quadratic formula and that would work, but it's a little messy. And so what we're doing, the whole reason I'm doing this problem is to show Vieta's formula. And so we're not going to solve it by factoring our quadratic formula, we're going to use Vieta's formula on this. Before we get to Vieta's formula, I'm going to do a little cleaning up on this expression right here. We're just going to get a common denominator by multiplying top and bottom by, in this case, beta, and then for this one, alpha. So then we can have our common denominator, alpha times beta, but on the numerator we'll have alpha plus beta. So this will be just a little easier to deal with here in a minute. And then next you might want to know, what is Vieta's formula? How do we use that? What does it mean for this quadratic? So Vieta's formula gives us a simple way to get the sum and products of the roots. They're not actually asking us to find the roots alpha and beta. We just have to find the sum divided by the product of the roots, and that's exactly what Vieta's formula does. So, and then let's just look at a generic polynomial to start rather than the polynomial we have on the left. So we'll look at ax squared plus bx plus c equals 0. And then Vieta's formula tells us that the two roots, the sum of the two roots of this polynomial, alpha plus beta, will be this value, but negative b over a. And then for the product of the roots, alpha times beta, that's just going to be c over a. And keep in mind, these roots don't have to be real. So there can be complex roots here. And it doesn't matter, and it'll still be the same value. So for the sum of our roots, alpha plus beta, we're going to have our b value, which is minus 36, but it's a negative, so that's going to make it a positive 36 over 46. And I'm not going to bother to reduce that, and you'll see why in a second. And then for the product of the roots, we're going to have our c value, which is 11, over our a value, which is 46. But our goal in this problem is actually this value. We need to find the sum over the product. So what we'll do is we'll divide, we'll have our sum 36 divided by 46 over 11 divided by 46. But then the reason I didn't reduce here is because our 46s will just cancel, and we're left with the answer of 36 over 11. You could write this as a mixed fraction as well. One thing I did to check my answer before the video was I actually did find the roots by using the quadratic formula. So if we did that, we would actually have using the quadratic formula, we'd find our x is equal to 9/23 plus or minus square root of 182 over 46i. It's actually pretty easy to see what happens when you add the roots, because you have a plus or minus, the imaginary part will cancel out, and you just have 9/23 plus 9/23 is 18/23, but that's the same thing as 36/46. Now when you multiply these two roots together, it isn't too bad because you have plus or minus, so you have a difference of squares, so it's not that bad, but you do have some pretty big numbers here, but I'll leave that to you if you want to check that. But what I did find was it reduced to this number 11 over 46, so you can check that. I got this problem from the quiz on my webpage, Vieta's challenge. I'll provide a link in the description. It also has similar problems for cubics as well.